Hi everyone, thank you for this introduction. I would like to first ask before presenting, has anyone heard about flexitarianism? Well, flexitarianism is an increasingly popular plant-based diet that aims to reduce our carbon footprint and to improve our health through a shift toward vegan and vegetarian foods, but with occasional meat or fish dish. The rise of the flexitarian diet is a result of people taking a more environmentally sustainable approach to what they eat by reducing their meat and dairy product consumption in exchange for alternative plant sources. It is attracting more and more people. Maybe you are becoming a flexitarian too. And as a result, you may have seen on the agri-food markets that more and more vegan, vegetarian, and dairy food products are launched. A 25% increase in vegetarian product launches between 2012 and 2016 was reported, and a 200% increase in vegan option during the same time. This shift in consumer preferences is putting the spotlight on plant-based ingredients. And so it's driving innovation across a multitude of product categories. Therefore, formulating a plant-based product requires product developers to rethink and to recreate the organoleptically pleasing and functional properties. In dairy products, milk fat is an important ingredient, and its crystallization has a significant impact on the structure of the product. But milk fat is complex, and replacing it in dairy alternative products, well, it's not an easy task. So the work I'm going to talk about and the work we've done involves blending two vegetable fats, cocoa butter and coconut oil. The first one is extracted from the cocoa bean that you may know in many chocolate products. And the second one is produced from the cocoa nut. And both of these fats are solid at room temperature, but they have different chemical characteristics. For example, cocoa butter, on the one hand, contains long-chain saturated fatty acid and also unsaturated fatty acid. It has fast crystallizing properties. On the other hand, coconut oil has high amount of medium-chain saturated fatty acid and high oxidative stability. Fat and oil blending are widely used in food industry. It's allowed to produce blended fats at an affordable price. And blending of vegetable fat with different properties is one of the simplest methods to create new products with desired specific properties. But here in our work, mixing cocoa butter and copra oil induced the depression of the melting point, the solid fat content, and the hardness relative to either pure fats. This kind of mixing behavior is typical when you have two solid fats that are immiscible. A solid immiscible fat led to eutectic phase. Eutectic fat mixture, it comes from the Greek, it means easily melted. Here, this is due to the structural differences of the molecules of the two fats, leading to fat incompatibility at different scale of organization. So the aim of this work is to investigate this eutectic behavior by studying the blending fat structure at different scale. We also analyze the structure of the fat blend from the centimeter scale down to the micrometer scale using a multi-technique approach. And the second objective of this work was also to understand the dependence of other factors, such as crystallization temperature on the eutectic behavior also of these blends. Thank you for your attention.
Thanks, Julie, for a great presentation. I did get a chance to introduce you. You're a PhD candidate at the Paul Pascal Center for Research in the University of Bordeaux. So really enjoyed your talk, and we're going to open your talk up to questions from the judges now.
who goes first? Philip, your turn. Philip.
Okay.
Okay. Go ahead.
Thank you, Julie, for the talk. Well, it was a bit more difficult to follow because we didn't see the poster. So that's my comment, maybe in general on the talk. But okay, it's an interesting topic for sure. So you mix, in fact, coconut oil with cocoa butter. They are both plant-based. But okay, why should you choose one or the other? Then there are some factors in choosing them in food industry, of course.
Well, the objective of my thesis was to use cocoa butter for sure.
Yes.
Why we use coconut oil? We wanted to have a solid fat with high amount of saturated fatty acid in order to have the advantage of the saturated fatty acid. So we didn't choose palm oil because of the environmentally sustainable approach that the consumer wants. So that's what we use coconut oil, and we blend it with cocoa butter.
Okay, and what is the product that you're targeting? So as I understand correctly, it's milk fat replacement by a blend of these plant-based fats.
Yes, well, it's a long way work because I just beginning my thesis. The first objective is to understand the cocoa butter and copra oil blending, but at the end we would like to put this fat into emulsion, and so that's why I talk about milk fat, is because maybe by emulsifying these two vegetable fats, we will be able to have this kind of textural properties that we have with milk fat.
So you're targeting a dairy cream, in fact, or yeah, something
yes,
like.
Well, it's very fundamental for the beginning, but we will see at the end if we have this kind of
well,
texture.
you mentioned in your poster that you do a multiscale approach, so you also study the nanostructure, but I do not find any results in the poster. Can you say something about that? What you really do on that structural level?
Yes, we did this multiscale approach on the poster and only represent the microscale and the macroscale. But we are right now going to analyze the nanostructure using X-ray diffraction at the University of Bordeaux. So it's just new. We just began last month. So we would like to see, in fact, yes, if, well, first of all, we have kind of cocoa butter polymorphism depending on the crystallization temperature first, and also if there is what kind of molecular packing we have regarding cocoa butter when it's mixed with coconut oil.
Yeah, I think this is quite important to understand because
yes, this
complex
would be the big next step.
Yeah, indeed. Okay, thank you.
Yeah, I was just wondering, you mentioned that you're planning to test out different crystallization temperatures and to explore the effects on melting temperature. Is that correct?
Yes.
Okay. And then I was wondering if there's anything else that any other processing parameters you might be considering testing to see if that might influence the product properties and behavior.
Yes, good question. Well, we regarding the crystallization temperature, we will also we have already tried to see if there is an impact when we do tempering, because cocoa butter is kind of a polymorphic fat. So we did also a tempering, a pre-crystallization step before crystallization to see, yes, if we have this the different results. And also during the next years, we will see if there is an impact of shearing. First of all, see if there is an impact of shearing at a lab scale, and maybe when we will put this kind of vegetable fat into emulsion, We would like also to see if doing shearing in a surface scraped heat exchanger will also impact, and we will change the textural properties of the final fat mixture.
Okay, thank you.
Yeah, hi, Juliet. I think it's very interesting, but I agree with Philip that you had a lot of nice data and pictures in your poster. It would have been so nice if you also put in the slides for in future. I think it's a great prop for your storytelling. Now, the work you have done, I mean, isn't it very similar to studying cocoa butter substitute and cocoa butter melting behavior and crystallization behavior, CBS and cocoa butters?
Yes, well, CBS, well, so you're right, but sometimes CBS is, so cocoa butter substitute, like lauric fat, like coconut oil or palm kernel oil. This work has already been done, but sometimes they just only mix a few percent of this lauric fat with cocoa butter, so they don't have this. They don't really use and use and put the spotlight on the eutectic behavior when we mix these two kind of fat. And here we also want to go deeper in this multiscale approach by really comparing when we will have SRG result, when really comparing the molecular packing with the microstructure we have and the textural properties of the fat blend at the end.
Yeah, because I think, if you want to go into the non-palm origin fat route, then you have to often probably compare with the standard CBS, the fully hydro palm kernel stearins. And one other question that you had these SFCs in your solid fat content data, right? So which method did you use? Did you use the long method or also for the blend different quick tempering method? Which tempering method did you follow?
We only did for the SFC that I present in the poster, crystallization during 19 minutes at 4 degrees Celsius, but we didn't do, for example, the AOCS tempering method. But we will do it because in order to obtain this the more stable polyformic form of cocoa butter, for sure, to see if there is an impact at the end.
And I'm sure we'll hear more from you. And I think one final comment that, when you have the fat phase ready, if you're going to make actual chocolates, keep an eye on the demolding behavior of the chocolates, because the companies who love to have a shiny surface with their logo on the chocolate. So for them, the demolding properties of the chocolate tablet is also very important. So keep an eye on that. And
yeah, that's good.
Next time when we meet physically, bring some samples. I'll volunteer to taste it. Thank you.
I will be pleased. Thank you.
Excellent. Hey, Julie, we have one question from the audience, and it states, can we have this liquid behavior by mixing other fats?
Yeah, sure. Well, as I told Christophe, we have this eutectic behavior when mixing cocoa butter with other lauric fats, such as palm kernel oil. But if I may remember, well, we have also milk fat with when we have milk fat in high quantity, when it's blended with cocoa butter, we may have this kind of eutectic and incompatibility.
Great. Thank you very much. Enjoyed the presentation very much.
You're welcome. Thank you.